Hello everyone, and thank you very much for joining me today. This is the first episode of a new series where we discuss data structures and algorithms as they are applicable for the Java developers. I don't plan to teach you a lot of theoretical things, but on the contrary, I would like to go through all the essential practical stuff that you need to know as a Java developer in terms of how things work behind the scenes, but also what kind of algorithms, data structures, and combinations of them might you need to use in real world scenarios. I hear always people complaining, hey, we have to learn a lot of data structures and algorithms at the university, but we don't use them at all in real life. Like, for example, why the heck would you learn how to sort a group of elements in 10 different ways, and then the only thing you need to actually do in real life is write arrays or arrays.sort? Well, yeah, that makes sense. I do agree with you actually, and I don't think that you need to learn 10 different ways by heart on how to sort groups of values. I don't know that either. So if you'd ask me now how to sort a group of values in 10 different ways, I might be able to show you a few of them, but I'm pretty much sure that I don't know by heart all the possible ways in which you can sort a group of values. But do I actually know what's behind, for example, arrays.sort? Yes, I do. So that's the idea. I know when I use something, I know what's behind the scenes, and I know that what I apply really applies to my situation. So the thing I actually want to teach you in this series is not how to, for example, sort a group of values in 10 different ways. No, that's not my plan. I want to show you those practical stuff that you need to know as a Java developer for the Java developer. And today we start with a basic question. Do you know what's behind ArrayList? We use ArrayList a lot, no? So that's, I can actually already start sharing my screen because I'm going to start drawing something, and then I'm going to start writing some code. You know, we use ArrayList quite a lot. No, it's maybe the default list implementation you use as a Java developer. So whenever you think about a list, probably the main instance you create is a new ArrayList or something like that. And sometimes we use linked list, but be honest with me. How many times did you actually think before writing new ArrayList whether should I use linked list or not? And maybe because you don't necessarily know how it's implemented and the difference between them wherever they are applicable. While it's true that ArrayList fits in a lot of scenarios, it may be better in some of them if you use linked list. Today we are discussing about ArrayList. I want to discuss with you how ArrayList works, what are its advantages, disadvantages, and explain them with diagrams and code. So bear with me here and let's start the discussion. So first of all, I think you can imagine it's called ArrayList for a reason. It's called ArrayList. No, I think we all understand why it's called list, because it's a list. It's that kind of Java structure that has an order, that it's indexed, and which allows duplicates. No, on the opposite to sets which are not ordered, they are not indexed and they don't allow duplicates. We know what a list is. I do expect that before starting our discussion now in this series, you already have as a prerequisite at least the Java fundamentals, which you can, by the way, find for free on the same channel. And if you are here with me live, and I see a lot of you, hey, live with me here, you can start discussions and share questions in the live chat. If you're watching the event recorded, of course, you can use the comment section, and remember that you can also find me on X and LinkedIn, X being the X Twitter. Okay, fine enough. So it's called ArrayList because it's a list that is backed by an array, meaning behind the scenes it uses an array, a simple array structure. And you can imagine, I think the default is 10 elements, so it's an array of 10 elements. So this is my representation of an array. Like I will be drawing it very ugly because I don't want to spend a lot of time on details. I want you to focus on the explanations, of course. So let's say this is an array, and like any other array, it's an indexed structure of variables of a defined fixed length. Whenever you create an array, you have to define the length, define its length from the very beginning, and you cannot change the length of that instance. And of course, you hopefully are already aware that arrays start with the index 0 in Java, and the index is an integer which increments with every next variable in the array. So that's why the second variable in the array will be 1, the third will be 2, and so on, and up to the end. And depending how many variables, depending on the length of the array, the last index will always be n-1, where n where n is the number of variables in the array. So exactly how many variables you have in that array. Well, this kind of a structure is used behind the scenes by ArrayList. So what happens is that when you create a new array list and you say something like, by the way, let's create a new project for that now. So we should create a new project, say just a new empty project now, and data structures C1 E1 or something like that. I want it to be with Java, and it can be with Maven, and let's start it in this window. Okay, just a little bit, so we have it indexed. And yeah, I was saying, if you create a new array, like just using the constructor without parameters, what happens is that the list behind the scenes will actually have an array. And again, if I correctly remember, it's an array of 10 elements by default, or something like that should actually be. Okay, finally loaded. So I'm gonna write here ArrayList of, you usually use generics, so all the collections in Java have been enhanced with generics, starting with Java 5, if I correctly remember. And if I write something like this, then I have an object that by default has an array of 10. Let's go inside and say initial capacity. Where was it? So initial capacity, you can see it to be 10 here. So that means an array of 10 values. Cool. So in that case, what is the conclusion? Is that it is an empty array, so you can add or set values, and you can also get them. And I think whenever we discuss about a collection, maybe the most important, let's say the most important 4 actions that you do with such a collection is you either add a new element, you remove an element, you set an element at a specific location, and sometimes it's not the case with ArrayList, because I don't think you can do that, but in general you could actually have also an insert, so something like this. So these are often the most, and the get, of course, sorry for that, and the get, the retrieve, the retrieve of the value. So these are the most often operations we are interested in when we discuss about a group of values, and the list is a group of values. So what is essential to observe, knowing that behind your array list you have an array, is that whenever you make a get, you will have to get a value from one of the existing indexes, depending on how large your list is. But regardless of which is the value to which you refer, it will be instantaneous. So it's a very low complexity, because actually a get is equivalent to saying the values array, or whatever you name it, at the position, and the position for which you want to get the element. So get the element at a specific index has the lowest possible complexity. It's instantaneously accessible, so the method will return it. On the contrary, when we work with an addition operation which adds a value on the next index, there might be situations where you can add it directly, but from time to time the entire array behind the scenes has to be enlarged. So let's assume, for the sake of the example, that initially you only have 5 variables, okay, and you already filled in all those 5 variables. At the moment the array behind the scenes is full. Does that mean you can't does that mean you can't, for example, add one more element to the list? No, it means that when you try to do that, it will be the array behind the scenes will be enlarged, meaning it will create a new array which is one variable more than what you had. And there are different strategies now that you can use here. So thank you for your feedback. I just moved a little bit farther away from the microphone, sorry for that. But that means that adding one more element sometimes has a higher complexity. And also, if you think about removing, so removing an element, unlike adding, will never need more values. So you will always have enough variables when you remove, because remove of course means getting out one more value, getting out one value from the array, which doesn't imply you need more variables, but on the contrary that you need less, so you don't have to do anything about it. However, it means that when you delete a value, when you remove a value, all the other values need to be shifted to the left with 1, because you cannot leave empty indexes. No, there are no such things as empty indexes in a collection. An index that exists should always lead to a value, whichever that is. So that's basically still creating some complexity. No, it's removing and adding values might be operations which complicate things from time to time. Setting a value at an existing position, however, if the position already exists, is same, very natural, is direct, has the lowest complexity. And insert, same as remove, might create a higher complexity. So if you take a look as a summary, you could say that when you use ArrayList, you have an immediate access to the values, which makes the get and the set to have the lowest. So these are to our lowest complexity, while adding, removing, or inserting have a higher complexity. So when you choose working with an array list, you might want to think about which operations will happen more often to that list, because you might be in situations where you have to just create a collection of values at the very beginning, and then you only get and set values. And in that case, working with array lists is perfect, because you use a collection for which the operations use the lowest complexity. But if you, for example, have to use that collection and the majority of operations are mutation operations, like the ones you see below here, the add, remove, or inserting values, then it's definitely a less good choice, and you might want to think about using some other kind of collection. I don't say now that in all cases where you have many mutations, for example, it makes sense to use something else. It really depends on the case, and it's still you, the developer, to figure out whether it's better for you to use one implementation or another. But knowing this now, have in mind that. So what do you say? Do you want to start implementing our own array list? So I don't want, we already know how to implement an array list here. So to instantiate an array list, we want to know how to implement our own, just to have in mind step by step. It's always better when when you create something from scratch, you also understand better how it works. So let's say that I create a class which I name AList. Of course, I don't want to name it ArrayList, because then I might run into conflicts with the class from Java util, which comes with Java, but we want to implement something similar. So this AList is, say, our implementation for an array list, and I don't want to implement now all the possible operations. It can stay also as a homework for you if we don't manage to do that in a given short enough amount of time, but we will try our best. So what I'm gonna do here is I'm gonna say I have a list. Yeah, that's my list of values behind the scenes, and initially, well, if you write a constructor, you might want to have a specific default value, same as you have with the array list. So in case I want to know how many values, because this is only a container that supports a maximum of 10 values, but how many values do you actually have here already? Answer is no value. So at the moment, if you would actually want to get a value from a specific index from the list, what would happen? So the question is, if you have an array list, like this one, what happens if you say list get the value from 0, and print it in the console? Well, if you try something like that, we should expect you get it's called index out of bounds exception, which is similar to what you know as being array index out of bounds exception for arrays. It's this index out of bounds exception tells you, hey, there is no index 0. But is that true? Is that true technically, that there is no index 0? No, there is an index 0 there actually, because initially you have behind the scenes an array that's backing this array list, which has 10 variables. No, 10 was the default we saw in the implementation. So there is actually an index 0, but from the list point of view, there is no element. So from the list point of view, for the moment, it's an empty list. That's why it also makes sense to have a different exception. No, it didn't throw you an array index out of bounds exception, because normally this is not an array index out of bounds exception. The array behind the scenes has the index 0. This list is the one who doesn't have the index 0. And you try to access an index that doesn't exist, not in the array that backs the array list, but in the list itself. So you always need to keep track of which is the size of the array. So this is it. So you need to know. So by default, the size is 0, regardless of how. So you can even say size 0. No, size is 0. I know it is the default in Java, but just to be very explicit, so you create this with size 0. So now what I want to do is Copilot seems to be very, very nice with me and tries. Let's see if it's correct. Let's see if it's the same thing I want here. So it actually we actually try to add a value, and you say if the size is equal to the length, then it means that we are in the situation where the container that is behind our array list is full, so you need to enlarge somehow. You need to enlarge the list. If not, you simply have to add the value. So let's say we will use this implementation the way Copilot provided it to me. By the way, I started playing a lot with AI tools, but I want, even if I didn't write it, first of all, I want to cut this out here, and exactly, I want to have it in the pure way. I don't want to use the array copy function. I want specifically for this case here just to copy the array for you to be clear enough what happens. Oops, like this. And please disregard a bit this if here. So take a look only at this method. In the pure situation where you didn't already add 10 values in this list, the only things that happen is that the newly added value will be added to the existing index equivalent to the size, and then the size will be incremented, meaning you have added one more value. If we go to the diagram, let's see what this actually means. No, so for the moment, let's actually say this is, so what I will do is 1 2 3 4 5 6. So this is 5. No, it's the list index. So what do we know now? We know that we have an array which has the length 6. The first index is of course 0. The last index is of course 5 because it's 6 minus 1. 1, 2. So 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. What the heck? Did I count them? Yeah, sorry, it's 7. I didn't count it correctly initially. Sorry for that. Okay, so 7. So 6 here. So it was it's again 7 is the number 1, 2, 3, 4, 5, 6, 7. So the last index is 7 minus 1, 6, and of course the first is 0. So the length is 7, but the number, the size, is 0 because you at the moment haven't added any value in your array list. So when you call the add method, what should happen is that on the first empty index, which happens to always be equal to the size. See, if the size is 0, the empty index, the first empty index is 0 as well. Whenever you have added an element here, say you added the number 15, then the size will also be incremented, will become 1. No, because now you have one value. And automatically the size will not only be the size, meaning the number of values, but will also be equivalent to the next empty index in your array that backs the array list. Okay, so see, it's very simple. It's always, the operations are always on the values of size. You put the value, okay, or what is the name we gave it? List. Okay, in the list on the index given by the size, which is always, we just figured out, no, it's always the next empty value. You add it, and then of course you need to say somehow that the size is now larger because you just added one more value. So automatically in the group, in the collection, you have one more value. Pretty easy, no? And always, when you always add one more, you'll always experiment the same thing. So next time you add one more and one more and one more and so on and so forth. And at some point you end up having 7 values. So at some point, the size now is 7. And guess what? The size was also the last empty index. But we have a problem. And the problem is the last index is 6. So we are in the situation where the last index is smaller than the size, smaller than the first empty index. There is no more empty index. That's how we can translate this. Okay? And we can see it graphically here. No more empty index. That means that if you execute these two, what will we get in that situation? We will get an array index out of bounds exception, which is that language exception thrown by Java thrown by the JVM whenever you try to access an index of an array that doesn't exist. Cool. So the two instructions, which are these two here, lines 21 and 22, were enough up to one point. And that point is when you ended up with the list full. So when you ended up with the list being full, they are no longer enough. And what the algorithm does here, and now I want you to focus because hopefully you understood lines 21 and 22. Now let's focus on the need of this size. What this says is when the size becomes equal to the length of the container. So in my case, going back to my diagram, when the size becomes equal to the length of the container, so we reached this situation where these two cannot be used anymore because they will run into an array index out of bounds exception, being that there is no more empty value, correct? In that case, we need to create a larger list. And now, of course, there are different strategies. How much larger? In this case, for example, we just enlarge, creating a twice the size list. You can simply enlarge it only with +1. And I'm not 100% sure, but I think that the ArrayList actually enlarges with +1. Let me check in the implementation, no? So somewhere here it's a grow, see, which ensures the capacity, okay? And it calculates a minimum growth, but you see that it also sometimes uses a growth only of 1, meaning just add one more. Now I don't think that actually one more is smarter all the time. I think basically is depending a lot on what you implement, no? Because depending on your case, you might know that you need twice the size, but you might know from the very beginning that you need 10 times the size, no? So you might know from the very beginning how much larger should the array become. But we don't really care about that, because like the only thing that makes sense for you to remember is that it needs to become larger. No, you need at least one more empty variable, because otherwise the add would not be able to add the value. So what this if makes here, it makes sure that it creates a new list, a new array called here new list, whatever, which is empty in the beginning. It copies from the existing list, so the container which is small, it copies all the values and then reassigns the reference so that the new list becomes the actual list. So what it does, it copies, it actually creates a list which is twice the size. Oh man, where do I put this? So let's do it like this. So this is the new list here, okay, which initially is empty. which is no longer 7 variables but 14, sorry. So I will not start drawing 7 more, but you can understand they are more here. Okay, the way we wrote the code, they are twice the size. Okay, so even more here. So we can take this and align them as well. And now here you have 7, 8, 9, 10, and so on. Okay, and so on. I will not draw further because I think you got the idea. And this is this line here, line 15. Line 15 is the one doing exactly this, creating one more array which is empty and twice the size, so it contains 14 variables. Why twice? Because that was our decision. Like, you could go with size plus 1 and then it was only one more. It's your decision how much would you like your array to grow, but it needs to grow at least with 1. In our case, it's twice the size. We just doubled the size because we are expecting to need to add even more values. And then what it does, it parses through this list and copies the value one by one in the new one. So it takes it one by one and copies the value here, 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 here. And then it gets completely rid of the first one. So it says this one should not exist anymore. Of course, what we didn't do is have the length of this one, which is double, no, in our case. And then what it does is it says I reassign the new reference to the variable. This one completely disappears, and now we have a larger container. Having a larger container, you can continue with the same instructions and add whatever value next. Until what point? Until exactly the same point when the size will be equal to the number of variables in the container. So exactly the same. So you will be able to add again, and when it happens again, you need to again enlarge the container, and so on and so forth, up to how many values you want to add. There is no logical limit in an array list. The limitation is, of course, by memory. If you can't add an infinity values. At some point you will run out of memory and you will get into an probably out of memory error in Java. But from a data structure point of view, there is no limitation. Every time you enlarge the container behind the scenes. So do you understand now why adding has a higher complexity? Because depending on how many times you reach the situation where you enter this if here, the complexity becomes O of n, meaning you have to go with a loop through the whole array and copy the values. So in the majority of cases, the complexity for adding a value is small, but from time to time you get into enlarging the capacity because the capacity of the container behind the scenes will not be enough anymore. And in that case, the complexity becomes high. That's why if you know from the very beginning that your array list needs more values, a larger initial capacity, it's always good to give the initial capacity from the beginning. So instead of starting with 10, you can from the beginning say, hey, I will most likely use a maximum of 100. What happens is that you occupied some memory, but you will most likely, if you never reach 100, you will most likely skip executing these lines of code. The compromise you made, because it's always a compromise, is between having to copy the values of the array by parsing through the array to create a larger container, or occupy more memory from the very beginning. So it's a compromise, but sometimes it's smarter. Sometimes it's smarter to avoid running the so-called growth of the container by making sure that from the very beginning you have an initial capacity that is big enough. Question here. So is the size same as the capacity? In my case here, the size is the number of values inside inside the array, while the capacity for me is the length of the list. So for me, no, for me the capacity means how many values can the current container behind hold. You might have, for example, as in our case, a capacity of 14, but you have only added 7 values. So for me, size, it's 8 in this case, sorry, 7 being the n minus 1. So for me here, the size is 8. We have 1, 2, 3, 4, 5, 6, 7, 8 values. But the container has a capacity of 14, which means I still can add 6 more values until I reach the point where I have to enlarge the capacity. I hope that makes sense. Now, of course, to remove a value. Now, let's take the set. Let's say I want to implement setting a value. So public void set of a value to a specific index. Look at it. Look at the set. So the set and the get. Oops, sorry for that. Look at the two. The set and the get, I didn't create them all. The set and the get, they are instantaneous access to the value. Of course, whatever I would have done here also is making sure that the index exists. So I would like to make sure that I catch the array index out of bounds exception and probably throw an index out of bounds exception in that case. Okay? I don't want to expose outside the array index out of bounds exception. So if the value doesn't exist, if the index doesn't exist, it should throw an exception. Moreover, remember that the index may exist in the container. But even so, even if it exists in the container, it doesn't mean that it actually exists where? In the list. Because that's what the size actually tells us. So in my case, I need to actually figure out if the index is smaller than the size, then you can add the value there. Otherwise, you have to throw the index out of bounds exception. Okay? So this is actually how it should look, but still, the complexity is small. You don't have a loop. You don't go through the array to read the values. You just have to know the index, either set the value or throw an exception depending on the case. If the index doesn't exist in the list, then you have to throw an exception, okay? Question. When adding an element, the complexity will be O of n plus 1 when the array is full, and O of 1 when it is not. Is that right? Yes, you understood it correctly. Perfect. Then the get, of course, the same thing. So yeah, now I see Copilot actually started learning from what I'm doing here. So I will try using it because it's fun. But the idea is the following. If the size, the index is smaller than the size, meaning if it exists, yeah, if it's from 0 to 7 in my case here, because here for me the size now it's 8, no? Size, it's 8. So why is the size 8? Because the size represents the actually the values that have been added, which are 8 in my case. 1, 2, 3, 4, 5, 6, 7, 8. While the length represents the total possible variables I have now in the current container, 14 in my case. No? So in my case, for example, a set at the index 2 works because index 2 exists for the collection. A get of index 2 works as well because index 2 exists not only in the container but in the collection. But if I would try to set a value at index 8, that doesn't work. Because 8, although it exists in the container behind the scenes, it doesn't exist in the collection yet. Yeah? Remember, there is a difference between the index of the container behind the scenes and the indexes of the collection. The indexes of the collection are only the populated already indexes from the container behind the scenes. So that's why for the get and the set, we also need to make sure that we are within the bounds of the collection and not within the bounds of the container. Yeah, the container is just there to support us storing the values, but we always focus on the dimensions of the collection. So that's why this condition is needed, and we need to throw index out of bounds exception in case we are outside the indexes of the collection. Now, if you want to remove a value from an index, okay, let's see what it does here. I see it throws exception if you are outside, and then if the index is smaller than the size, then of course you can't remove something that doesn't exist. Otherwise, it goes through the collection and grabs everything to one, and then okay, it looks fine what it did here. Now I will explain it line by line. So to remove the value from a specific index means that, okay, this sketch is the easiest to understand. Okay, I think I will start with it because it's the easiest. It means that if you try to remove value 8, it will be an exception because the value on the index 8 doesn't yet exist in the collection. Okay. Clarify the difference between set and insert. Good one, thank you very much. Set is when you override an existing value in the collection. So you have, say, a few of them. So even take it here. When you set a value at index 2, say you set value 60 at index 2, it means that you replace the 9 here with 60. Inserting mean you want to push a value between the 7 and the 9. So you don't want to remove the 9. You want to insert the 60 before the 9 such that the 60 becomes the one on the index 2 and the 9 and all the other values are shifted to the right and the array becomes larger with 1. So inserting means you add a value but in the middle of the array, not at the end. It's not something that you have in the array list. I just wanted to mention it because it's a general operation for such kind of containers, for such kind of collections. Yeah. But the difference between set and insert is that set just replaces a value, while insert adds a new value in the middle of the collection at a specified point. I hope that makes sense. Okay, yeah, so I don't need this anymore. So if you try to remove something that's outside the collection, index out of bounds exception makes sense. Okay, if you try to remove something that is outside the collection, even if it is inside, even if it exists for the container, still index out of bounds exception makes sense. Yeah, you cannot try to remove the 8 here even if it exists in the container, just because it's not in the collection. Remember, container behind is something transparent for us. We don't need to, it's just the support of our values. But that index 8 will not exist for the collection until the point we add a value on it. Okay, so that's why we have, oh, sorry for that. That's why we have the catch to catch everything, like any index outside of the container completely. The else here is to catch any value that is maybe exists in the container but it's outside of the collection. There haven't been yet added so many values, and you are on a value which is in the container, it exists there, but for the list it doesn't exist yet because you haven't added those many. Okay, and then of course if you are in a situation where you can remove a value, then what you do is you do it like this. Say I want to remove this 48 here. What do I do? The 48 will be actually replaced by 15. The 15 will be replaced by 98. And when you reached the index which is equivalent to the last element, we simply remove this value here, and that's it. And of course the size becomes smaller. So if you take a look here, what you will see, the only thing that's missing is the fact, which is of course not mandatory, you can remain with the applicator, but you could also say something like I plus 1 is 0. It's actually no, you don't have I plus 1 because it's outside. Size is 0. No, let me check on the diagram to make sure I'm not. So size was still 8, no, at that time, so was 8, and then I put here 0, and then I make it smaller with 1, and it becomes 7. So yeah, that's the correct. Okay, so and take it in my case, for the simplicity, I created an array list of ints. Normally it would be of objects, and instead of 0, then of course, because it doesn't maybe really make sense, you would have null here because it should be object. No, maybe at the end we can try replacing this and making it more generic with using even generic types. Okay, because it's not that difficult in the end. And yeah, that's the remove. So you see, removing, now going back to complexities, no? Removing is clearly higher complexity. Wherever you choose, it will have to go through all the values that remain on the right side of the selected one, and pull them back. So you will have to have a loop there. So unlike setting or getting values, which are instantaneous operations on the collection, removal is not instantaneous enough. And now if you want to also insert an index at a specific index, which was forced here was the index and the value. Okay, make the same index to the value, then it becomes even larger than this. Now it becomes a lot larger. And again, I will not explain anymore the catch and the else. You already got the idea, the container versus the collection. But you see that if you are in the situation, let's see if it's correct what it created here. So let me actually do it like this. Okay, so normally the only thing you need to do is to parse through all the values and move to the right. So say I want to insert the value 60. No, that was the example from the question. So I want to insert at index 2 the value 60. Okay, what do I do in that case? First of all, I make sure I have enough variables in the container, because if I have a full container, clearly I have to start first with enlarging the container, and that's why here you have on this line 69 an if. This is the same if that you have used when adding a value to enlarge it. See, it's clearly the same. Normally you would extract this in a different method. That's why if you take a look in the real array list, you have a grow method, because you need a grow on different operations. Okay, so this same as for the add, to insert you first want to make sure that the container has enough variables, because you are going to add one more. Like in the case of add, you will add one more. The difference between add and insert is that add always puts it at the end, while the insert is a little bit more difficult. It puts it somewhere in the middle, and that is specified via the index you want to push the value at. So once you have the if, making sure, oh sorry, not this one. Once you have the if, come on, the if making sure that you have enough space in the container, then what you do is you copy all the values starting from right to left, and 98 is no longer on index 6, it's on index 7. Then 15 is copied to index 6. Then 56 is copied to index 5. 75 and then 9, and at the very end the 9 is replaced with the value that you want to push in, 60. The size enlarges as well, because now you have more values with 1, and that's it. And that's exactly what happens here. So once you made sure you have enough space in the container, you go from right to left, so from size to the position where you insert, and you make sure you copy to the right every value. So in the end, in the middle, you remain with a value, and then at the very end you copy the value on the remaining index where you wanted to push it, and the size grows, like in my case, from 7 to 8. So this is shortly, with a simple, hopefully I managed to use a simple example, demonstrate the logic behind ArrayList, which I think every Java developer should understand. And now you know, when you use some operations which are more complex than others, you have implemented them yourselves. You will have this on my GitHub account, by the way. After the video, I will put it on my GitHub, and you can play with it if you want. And that's it. See questions. So I would appreciate to try CL class to step into functional programming at the same time that solve algo problems, make index of classes. I'm not sure I understand if it's a question or something else, so maybe you can rephrase, or we can take it later on social media, because I don't understand if it's a question. Next one, if our logic of code would be larger, then should we create separate class to treat the exceptions for the array lists? I would say, yeah, from a maintainability point of view, remember that we always have to have in mind the single responsibility principle. So yes, I would say I would recommend you separate things. Now, if you ask me, would I create a different exception than index out of bounds? Only if it helps me with something. Normally you can reuse any exception in the language, no? In this case it doesn't even matter, because it's the algorithm I wanted to teach you, not necessarily. Don't take this as a best practice for maintainability. Take it as an explanation for the data structure, because that's the plan. But I would say depending on the case, you can either reuse a class or you can create your own. Just remember to focus on keeping the responsibilities apart. What happens if we want to remove the value placed at the last index? Very good. So didn't I cover this case? So let's see if the size is 0, it will not work for me. No, that's what you say here. So I didn't cover the case where you have size it's 1 and you want to remove from it. It works actually. It works the same. No. In that case, sorry, I was on the remove, but it's the same thing. So you remove 0 is smaller than 1, it gets into this one. So what happens is that the for basically doesn't run at all because the condition doesn't match. It only gets into list size equals 0, and then size becomes from 1 0. So it works, it's fine, it works correctly. You can implement some unit tests for this. Now, normally I would implement unit tests for any algorithm I write, but it looks to be working fine for me. It will only basically get into decreasing the size. So it should work fine. Thank you for the question. So why is it list of size is 0, not list of size minus list of size minus 1? List of size is because it is before decreasing it. So you first make it 0. Now you removed it and then you decrease it. So let's get back here. So initially when you removed the value, you had 8. No. So when you remove it, say I want to remove this one just to be easier. No. So what will happen is that 98 will be brought to the left. Size is still 8. So what you want, no, because now you copied it. So now what you want is to make this one, okay, minus 1. Yeah, you are right. You're totally right. Minus 1. Good point. Okay, you caught me. But you got the idea, hopefully. Okay, so I guess that's it, and hopefully you enjoyed this video, and I hope if you didn't learn something new, at least that you had fun together with me and you saw that I might also make mistakes, and that's why basically I write unit tests. And again, I do advise you that always whenever you're writing such algorithms, you should write unit tests for each of them. Now this was not the purpose of our video and I haven't written any tests, but trust me, in real world scenarios I do that. This was the first video. Hopefully it is helpful for you. I'm looking forward to your questions in the comment section further, and of course remember that you can always follow me on LinkedIn and X, also known as Twitter, in the formerly times. Thank you very much everyone. Have an excellent day further and talk to you later. Have an excellent time for study. Cheers.